session about debugging all the tools presented in the Evolve event by Platform.sh on October 2024. The goal of this session is to provide you with a comprehensive understanding of how to effectively debug issues on Platform.sh and Sawssen using powerful tools like Logs, Xdebug, and Blackfire. Hopefully, by mastering these tools, you can significantly improve your troubleshooting process, identify performance bottlenecks, and resolve issues faster. So why debugging actually matters? Efficient debugging can save development time, prevent downtime, and ensure a better user experience. On a platform like Platform.sh or Sawssen, where multiple services and components are in play, having the right sort of tools is key to understanding and resolving issues. So let's start with logs, the foundation. The logs provide the first line of information when something goes wrong. Let's learn how to access different types of logs on Platform.sh and Sawssen. Logs can first be accessed for ongoing activities through the console, where you can simply click on the activity you wish to check the logs on, and then you can scroll, search, and share the traces. You can also use the CLI with the when you push a new activity, the logs are displayed in the console and in the terminal, and you can go through them. Application or container logs can be accessed through the CLI as well, using the access command, or simply by SSHing to the needed environment and navigating to the logs location, which is var/log for the main ones. Events that occur within an app container are logged within that container. Some of the logs are always available, like the access or the app ones. Some others are created only when the related activity runs, like the deploy or the cron ones. If your app has its own login mechanism, use it to write to a dedicated logs mount. Logs provide the raw data necessary for observability. It allows you to trace errors, investigate performance issues, and optimize your code by identifying bottlenecks. Both Platform.sh and Sawssen offer built-in login and observability features, including aggregated logs, which simplify debugging complex and distributed systems. Your app may output logs with distinct severity levels, but as Platform.sh and Sawssen only reads logs from stdout, this distinction is lost and everything gets logged at info level. To preserve the original log level, use a language-specific syslog module or package for login. Forwarding the logs to an analysis tool is very powerful and helpful. Integrations exist in Sawssen and Platform.sh with New Relic, Sumo Logic, or Splunk. You can also use any service that supports a syslog endpoint or an HTTP one. Think of dashboards. OpenSearch might be a good option. It lets you trace bugs by correlating logs with application behavior, and when combined with tools like Xdebug or APM systems, it offers a comprehensive solution for debugging and monitoring in production environments. Let's now move to Xdebug. For those who are not familiar with it, it's a PHP extension that enables advanced debugging features like breakpoints, stack traces, and real-time variable inspection. It actually enhances PHP's error handling and debugging capabilities by step debugging. It actually allows you to pause execution, set breakpoints, and step through your code line by line, inspecting variables and logic at runtime. It also provides detailed stack traces and error messages showing exactly where and why an error occurred, and it helps identifying performance bottlenecks by creating execution profiles that show the time spent in each function. Let's now go through the steps to implement or enable Xdebug on Platform.sh and Sawssen. First step would be to add the extension and the IDE key to the YAML app configuration file. If the router cache is enabled, add the Xdebug cookie to the cookie list. And you might need to think of enabling the PHP extension by adding it to the PHP INI or to the YAML file. It is also important to install a debug helper, can be a browser extension. Once the configuration files are ready, you can push them to the right environment, and that will redeploy it and enable the extension. Next step would be to configure your IDE. The one that I have used here is PHP Storm. Detailed instructions on what settings need to be added are available in our public documentation. Let's now start debugging. While in listen mode, start the Platform.sh debug tunnel. Use the Xdebug helper plugin for your browser to enable debugging. Set a breakpoint in your app. Then load the page in your browser. The request should pause at the breakpoint and allow you to examine the running app. Xdebug is ideal for in-depth, low-level debugging during development. You can use it in local debugging when you need step-by-step execution control to find bugs in PHP code, in advanced debugging to inspect stacked traces, variable values, and breakpoints, to profile as well to analyze performance issues like CPU usage or memory leaks, for code coverage to test how much of your code is being executed during testing, and for collaboration with IDEs when you want integrated debugging features in tools like PHP Storm or Visual Studio Code. What to keep in mind: if you are using Platform.sh or Epson, you can run it safely on production environment. I would still recommend to optimize Xdebug settings to control when it's triggered and making sure you're not running it unnecessarily. Monitor the performance impact still, and log the debug sessions to track any issues that might happen and diagnose any debugging configuration or process. Limit traces though. If you are generating traces for profiling, limit their scope to essential cases to avoid excessive overhead. Let's now talk about Blackfire. For those who are not familiar with it, it's our continuous observability solution designed to help developers identify and resolve performance bottlenecks in their applications. It provides deep insights into how code is executed, allowing you to profile, test, and optimize your application in real time. On Platform.sh and Epson, Blackfire integrates seamlessly, enabling you to monitor and fine-tune your app's performance without impacting production environments. Blackfire helps optimize an application performance across 3 key stages. Development. It is used for debugging beyond performance. It helps to understand how an application behaves, which functions are triggered, and in what context. During testing, it automates performance tests during staging to ensure smooth functionality and identify any performance issues before production. And in production, it is essential for monitoring live traffic, identifying high-resource transactions, and providing breakdowns of time spent in the app and external services like SQL or HTTP. Blackfire's profiler runs with minimal overhead, ensuring smooth production performance. So its key features basically are monitoring. It collects live performance data with very light overhead to detect bottlenecks in real-time traffic. Profiling, as it gathers deep insights like function calls, CPU time, memory, and SQL queries. It offers visual tools called graph and timeline to trace issues in real time. And then testing. It helps integrate and performance testing into CI/CD pipelines with assertions to ensure the app stays within performance thresholds. This makes Blackfire a comprehensive tool for managing app performance throughout the project's lifecycle. In the Blackfire profiling process, several components work together to collect and analyze data. The client, these are tools used to initiate profiling, such as the browser extension or the CLI tools like Blackfire curl and Blackfire run. Servers, on the back end, Blackfire's web app manages profiles and authentication, allowing users to view results. The probes and the agents. Probe is the lightweight extension for PHP, for example. It's a PHP extension. For Python, it's a pip package that remains inactive until a profile is requested. And then the agent is a daemon running in a container or on the same project that collects data from the probe, processes it synchronously, and sends the profile data to the Blackfire servers. So the profiling steps are basically the probe would be measuring function calls, memory, SQL queries, and external HTTP requests. The agent would then aggregate the data, anonymizes SQL HTTP queries, and prunes insignificant functions to present a clear profile. The authentication ensures only authorized users can run profiles, especially in production environment. All of this setup is automatically integrated with Platform.sh and Upsun, requiring minimal configuration. Blackfire collects two types of data, monitoring traces and profiles. The monitoring traces capture high-level performance metrics like response time, memory usage, with minimal overhead. They help quickly identify when and where issues occur in the code. While profiles provide more in-depth analysis but generate overhead, which only affects the user initiating the profile. Profiling is on demand, making it safe for production use without impacting other users. Additionally, automatic profiling happens every 24 hours on real traffic, creating detailed profiles of significant requests without burdening the overall system. Running a profiling session to collect the data on code execution times, memory usage, and database queries. And then, based on that, you can analyze the visual output to identify the performance bottlenecks, such as slow queries, heavy functions, or inefficient loops. It will be also worth mentioning to make sure to enable the debug mode, which is not the default one. In this video, we can see that we can easily compare two profiles. Those are automatic ones that have been triggered by Blackfire on significant events. And then comparison can help understand the application behavior and the impact on the resources usage and where and when we can probably help optimizing the application. So what to keep in mind when using Blackfire? Use it to monitor regularly your application performance over time. You can safely profile in production as it has minimum impact and limits profiling to essential users. Focus on relevant metrics. Analyze the metrics like memory, CPU usage, and SQL queries, and use the column graphs and timeline to pinpoint the bottlenecks. Let's now conclude with the best practices and some common pitfalls to avoid. Approach debugging systematically. Always start with the logs, then drill down with more advanced tools as needed. Regularly use performance profiling tools like Blackfire to catch potential issues before they escalate, and document your debugging process to help build a repository of solutions for future use and help other users. What to avoid? Basically, logs often contain subtle indicators of large problems. Neglecting to review them can lead to missed opportunities for early intervention, allowing small issues to escalate into significant system failures. It is easy to get distracted by irrelevant metrics, but the goal is to focus on bottlenecks that significantly impact performance. While powerful, no single tool offers a complete view of system behavior. It is recommended to combine tools like log analysis, performance monitoring, and profiling to get a well-rounded understanding of issues and avoid tunnel vision. One of my favorite code is, I think, from Philippe Fortes, the co-founder of Pixel Labs, is him saying debugging is like being the detective in a crime movie where you're also the murderer. And since I am a big fan of CSI, I thought adding, but at least now with all of the tools on Platform.sh and Appsam, you have a whole CSI team on your side. I hope you enjoyed this session. Please don't hesitate to share your feedback with us. Thank you.